Hello everyone, let us start with our question. In this question, what is given? A solid sphere of radius capital R and charge capital Q is distributed in its volume with a charge density is given as to be rho k r to the power a, where k and a are given to be constant and r is the distance from its center. Now we are given with that electric field at small r equals to r by 2, that is half of the radius, is 1 divided by 8 times the electric field at small r equals to capital R, and we need to find what is the value of A. So what we are given with? We are given with that electric field at small r is equals to r by 2 is 1 by 8 of electric field at a distance of r, that is at the radius. We need to find these values. So how are electric field given? We know the electric field formula. We can just write, or we can just first of all draw our diagram. So for example, this is our sphere on which charge is distributed, and sigma rho is given as to be k a to the r to the power a. Sorry, it is r to the power a. Okay, we can just write r to the power a. Okay, now on the surface, if we need to find the value of electric field, so what we need to find? We need to find charge which is enclosed by this surface. That means charge enclosed by the radius. Now, if you wanted to find electric field at small r by 2, for example, this is the center, and let's call this is the distance r by 2, or this is the sphere at r by 2. So in this condition, we need to find what is the charge inside this part. Okay, so first of all, we should write how our charge written. Okay, q value, we know that q value could be written as integration of what? Rho into elemental volume. So it would be for sphere, it is equals to 4 pi r square into d into r. Now what is the value of rho? Rho value is k r to the power a. So we can take this k common because it is a constant. So we can just write 4 pi k, and then there would be just r to the power a, then r to the power a plus into r to the power 2. So it would be r to the power a plus 2 into dr. Okay, now if we want to find the total charge, that means from 0 to r, that means total charge q would be equals to what? This would be equals to, we just change our limit to 0 to capital R. Okay, then it would be r to the power a plus 2 into dr. Now what we can do? We can just integrate it. So it would be 4 pi k. Now what is the integration of a plus 2? So integration of a plus 2 would be a plus 3 divided by a plus 3, r to the power a plus 3 divided by a plus 3. So this is divided by a plus 3. Okay, now what is the limit? So we need to put small r as capital R. So we can just directly put to save our step. So it would be capital R to the power a plus 3. This is the charge. Because this lower limit is 0, so there is no need to subtract lower limit. Now this is the charge. Now what would be the charge q? We can just write here small q. So small q value would be what? This is small q at r by 2. So we can just integrate this with a limit of what? With a limit of 0 to r divided by 2, r to the power a plus 2 into dr. Now if we integrate this, what would be our integration? This would be constant, and in the denominator we would be having a plus 3 similar to this. So we can just write a plus 3. Now what is the value of r? So r value is capital R divided by 2. So we can just write capital R divided by 2. And what would be the power? So here power would be a plus 3. Okay, this would be the case. Now what is given to us? This is the condition which is given to us. Now we can find the value of electric field. Electric field at a distance of r by 2 would be equals to what? We know that electric field at a distance of r by 2 would be equals to 1 by 4 pi epsilon. What is the charge? Charge value is what? 4 pi k into r divided by 2. This is the value of the charge, this whole expression. A plus 3 divided by what? A plus 3. So this is the value of charge. So electric field is written as 1 by 4 pi epsilon, then q divided by r square. So what is the distance? We are calculating this value for r by 2. So we just divide it by what? R divided by 2 square. We can just write it like this. Now this value is 1 by 8 of electric field at the surface. So it would be 1 by 4 pi epsilon. We can just write it like this, similar to this. Now what is the value of charge at the surface? It is the total charge, whose value is 4 pi k, then r to the power a plus 3, then divided by what? A plus 3. Okay, now we also need to write the distance, and distance would be equals to what? For the surface it is equals to r square. So it would be r square. We can just write it r square here. Okay, now how can we write? 1 by 4 pi epsilon, 1 by 4 pi epsilon is gone, 4 pi k is gone, 4 pi k is gone, a plus 3 is gone, a plus 3 is gone. So this value this we can write it as like this. R by 2, it is the same, R by 2, this and this is same, so we can just adjust the power. So a plus 2 minus 2, so it would be a plus 1. Now this is 1 by 8, so we can just write it as 1 divided by 2 raised to the power 3, and we can write this as this is capital R, a plus 3, and then power would be minus 2, so we can just write it as this, like this. Okay, now here r to the power a plus 1, here r to the power a plus 1, so r to the power would be gone, so here it would be just 2 to the power a plus 1 would be equals to 1 divided by 2 raised to the power 3. So if we compare the powers, we can say that a plus 1 value is equals to 3, which implies that a value is equals to what? A value would be equals to 2. So this is what we need to find. So we need to find the value of a. So a value is equals to 2 for our case in this condition. So hope you have understood this explanation. Thank you.
In this problem, we have given that 5-point charges, each of value plus q coulomb, are placed on 5 vertices of a regular hexagon of side L meters. The magnitude of the force on the point charge of value minus q coulomb placed at the center of the hexagon is. Okay. So we have to find the magnitude of the force acting at the center where minus q charge is placed. So at this location minus q charge is placed. Since it is a regular hexagon, so the angle, this angle is 60 degree. Okay, this angle is 60 degree. So as all the angles are 60 degree and the side of regular hexagon are L, so all sides will be also L. Okay, and this will be like an equilateral triangle. Okay, if we are going to consider this one will be an equilateral triangle. Okay, having all angles 60 degree, having all angles 60 degree. That means this side length, this length will also be L, this length will also be L, this will be L, this will be L, this will be L, and this will be L. Okay, now let's talk about the electric field due to the charge at the center. So we know that the electric field due to this charge at the center can be given in this direction. Okay, so consider this electric field as E1. Okay, and E1 is equals to K into Q upon L square, where L is the distance between the center and this charge, and at center there is a point charge minus q coulomb. Now electric field due to this charge at the center will be in this direction. So consider this as E2. E2 is again equals to kq upon L square, because this length is also L. Now due to this charge, electric field at this location will be E3, and E3 is also equals to k into q upon L square, because this length is also L. Now due to this charge, the electric field at the center will be in this direction. Okay, uh, away at the center, because the charge nature of the charge at on all the vertices on the hexagon are positive. So this is E4, and E4 is also equals to kq upon L square, as this distance is also L, and due to this charge the electric field will be in this direction. So this will be E5. Okay, and the magnitude will also be same. So we can see that E1, E2, E3, E4 and E5 all are equal in magnitude. Okay, now if we talk about the direction, E2 and E4 both are opposite in direction and same in magnitude. So E2 and E4 will cancel each other. So E2 and E4 will cancel each other. E3 and E5 both are equal in magnitude but opposite in direction. So E3 and E5 both will cancel each other. Now only electric field is present at the center is E1. So force on the charge, force on minus q charge placed at the center of center of hexagon can be given as force equals to Q into E. If we talk about the direction, since this charge is negative and electric field direction is towards left, so direction of force at the center will be towards right. Okay, so this will be the direction of force because nature of the charge is left. Nature of the charge is negative. Okay, and direction of electric field is towards left, so direction of force acting on this charge will be towards right. Okay, so force equals to Q into E, and this can be given as Q into electric field is KQ upon L square. So magnitude of the force will be KQ square upon L square, where K can be given as 1 upon 4 pi epsilon naught Q square upon L square. So finally we can say that the force acting on the charge particle placed at the center of a hexagon is given as 1 upon 4 pi epsilon naught Q square upon L square, and that is the answer of this problem. Thank you.